Prompt is, given a collection of intervals, find the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Here is my brute force method for solving the problem. So here is remove min intervals. It takes in intervals, the list of lists that we see here, and I have four test conditions. So we take the original length of intervals and assign that to count, and then we run a recursive method here called remove min intervals helper. So what this does is it takes in intervals as an argument, and then it pops the elements within intervals that overlap the most. So after we've popped elements from intervals, the length of intervals will have changed, so we'll subtract the original count, the original length of intervals from the new length of intervals, and that will be the count of the number of elements from intervals that have been popped. So here's my recursive method, remove min intervals helper. We set the, so what this method does is it looks through the list of elements, and it will remove the element that intersects with the other elements the most. So here's max index of 0, max overlaps of 0. We haven't done any work yet, but we're assigning our variables to keep track of information. So here's a for loop. We're looping through the list, and then we have another for loop. We are looping through the list again, so we are comparing each element with every other element in the list, and then we're going on to the next element, comparing this with everything else to see how many intersections there are, and then we're looking at this element, seeing how many times it intersects with the other elements in the list. So I have this condition here, if I is equal to j, continue, because we don't want to compare an element to itself. So I hope that makes sense. And then here are the overlapping conditions. So if the start, if intervals I, the start number matches with intervals I plus 1, or j, intervals j, so if the start number of the element of interest matches the start number of another element, and then also if the end number of the element matches with another n number of an element, then that's an overlap, right? So that's what this first else if condition is. We want to add 1 to overlaps for intervals I, and then here's another condition. If the start number within the element is between intervals the start and stop, the start and end numbers of intervals j, then we have another overlap. And then if the end number of intervals I is between the start and end numbers of intervals j, then we have another overlap. And then we have two more overlapping conditions, where if the start number of intervals j is between the start and end numbers of intervals I. then we have another overlap. And then also, if the end number of intervals j is between the start and end numbers of intervals I, we have another overlap. So we count how many overlaps there are for intervals I. So if the current intervals I has more overlaps than the previous max count of overlaps, then we want to update the index of the max, the index of the element that has the most overlaps. And then here I have the base condition down here. So if max overlaps is 0, so if we no longer have any more overlaps in the list, because we've popped every single element that overlaps, then we just return. Otherwise, we want to keep doing this method until we have no more overlapping elements in the list. The time complexity of the brute force method is n squared times n minus 1, which would be big O n cubed. So let's look at the solution here. So we have two for loops, and we iterate through n from 0 to length of n twice for each recursive call. And in the worst case scenario, we have one element. In the worst case scenario, every single element in the list will be the same. So we'll keep popping from the list until we end up with one element in the list. So we have n squared on the first recursive call, and then on the second recursive call we have n minus 1 squared. The third recursive call we have n minus 2 squared, all the way until we end up with one element. So that's how I get n squared times n minus 1, which is big O n cubed. I was also able to use the greedy algorithm to solve this problem. First, I sort the intervals, and it sorts the list of intervals by the start and end time. So this test condition here would be sorted as 1 2, 1 3, 2 3, 3 4. And then I loop through the intervals. If there's an identical start time, then I delete the latter element. So I initialize count to 0 and I to 0, and while I is less than the length of intervals minus 1, I test for if intervals I 0 is equal to intervals I plus 1 0, then I pop the element at I plus 1, and then I increment count. And if there's no overlap, then I increment I. Then I return count. The time complexity of the greedy algorithm is n, big O of n. And the reason for that is we are only looping through the list once, because we are comparing element I with the next element.